quantitative versus qualitative. Quantitative means numbers. Your continuous data from the previous slide and count data are quantitative in nature, quant, numbers, right? Qualitative means categorical data. Okay, so you're saying, I mean, this is very tricky, you know. If customer says, how much accuracy can I expect? If you say you can expect high accuracy, what do you mean by high? Right? So customer would obviously say, what do you mean by high? You say high means probably 80 to 85%. Now we are quantifying that qualitative statement. Okay, so that's very important. Next, balanced versus imbalanced data sets. When data is given to you, structured or otherwise, meaning structured or unstructured data, doesn't matter. When data is given to you, you'll have the output variable. Say you're trying to build a model which says whether a person will default or not default, and you have age, gender, income, all those, and say you have 1, 2, 3 in that way, some 100,000 observations. Here are 10,000 observations. Here, default will not default, default and no default. In that way, you have the data. So you have two categorical problems, two class problem rather. One is default, another is will not default. If you have 50% of cases which are default, 50% of the cases which are not default in your output, then that's balanced data set. If you have 60% and 40%, still it is balanced. If you have 70%, 30%, still it is balanced. Research says that if you have if one of the classes, 71, if one of the classes is less than 30%, so here one of these classes, right, not default is less than 30%. It could be something like 29% here or 71% here, doesn't matter. If one of the classes is less than 30%, you say that that data set is imbalanced data set. Okay. Why do you need to look into that? Two things. One, if you have imbalanced data set, then your standard random sampling does not help. Okay. This random sampling does not help at all, right? And then when you have imbalanced data set, you have to resort to a few other techniques which we are going to discuss. You know, what are those? A few other techniques: random resampling, undersampling, oversampling, stratified sampling, resubstitution, k-fold cross validation, right? Leave one out or k-fold cross validation, SMOT, synthetic minority oversampling technique, modified SMOT, cluster-based technique, ensemble techniques, bunch of those. Those are listed in the subsequent slides. Okay, don't worry. Okay, don't feel that this guy is trying to show off, but we will show those in the subsequent slides. Okay. And another thing that you need to remember is that whenever you have imbalanced data set, the accuracy of your model should be greater than the higher class. Okay, when I say higher class, here the class default has 71%. So your accuracy should be greater than 71%. Say you have 80%, 89% default and 11% not default. That means your accuracy should be greater than 89%. That is when you have your imbalanced data sets. That is a thumb rule. Take it with a pinch of salt. One is this, take it with a pinch of salt. Another is, if one class is less than 30%, it is usually called as imbalanced data set. But usually what people do is, They apply both the techniques. They apply random sampling, assuming it is balanced. And they'll look at the accuracy. They'll also apply imbalanced dataset techniques and see which technique is actually working well. Next, you have structured versus unstructured dataset. What do you mean by that? And also I've put it, and also semi-structured, we'll get there, but what do you mean by structured versus unstructured, and what do you mean by semi-structured, and what do you mean by raw format, right? So structured data means any data that can be represented in a neat tabular format, wherein you have rows and columns. That's structured data. Unstructured data is that data, right, which cannot in its raw format be placed in a tabular format, such as videos, images, audio files, and textual files. Okay, imbalanced dataset techniques we'll discuss in the subsequent slides. So let's understand this. Video is nothing but collection of a lot of images which are taken at a rapid pace. When you collect the videos at a images at a rapid pace, it's nothing but a video. And these are called as frames of images. If you have more frames per second, the quality will be called as high definition quality. Okay, simple. Now, so you have frames of images. Video is broken down into frames of images. Each frame is an image, right? And image, when you look at image, so image and video is one another same. If you have a video, break it down into frames of images and treat it as an image and proceed further. Image contains pixels, pixel values, and pixel values range from 0 to 255 if it's a grayscale image. Even if it is a color image, even if it's a color image, when you say it's RGB image, when you look at only red channel or green channel or blue channel, it is as good as looking at a grayscale image. Okay. Now, 0 means black. 255 means white. You take this first pixel value, put it in X1. Take the next pixel value, put it in second column. Take the third one, put it in third column, so on and so forth. Okay, you take each and every pixel value and put it in your data set. X1, X2, X3, X4, so on and so forth. Okay, so what are you doing ideally here? You're trying to take your image, which in its raw format is unstructured, and making it structured. So you can always make your unstructured data become structured. And pixel values are the most raw features. You'll have edges, you'll have blobs, you'll have texture, you'll have corner points. You have many things that you can extract from image. Whatever you extract, you can actually place it in a structured format. Good. When you have audio files, which is in unstructured format, in raw format it is unstructured, people apply techniques such as MEL frequency cepstral coefficient. And when you apply that, you can convert your unstructured audio file into a structured format. That means you can represent that in a tabular format. Then you have textual data such as social media comments, etc., etc. When you have that, usually people use document term matrix or term document matrix, term frequency inverse document frequency. Yeah, using those, you actually bring your unstructured data into structured format. Semi-structured means maybe you can think about IoT sensors data or server logs you will have like that text file, right? It's not in nice tabular format, but it's very easy to move that to structured format. You just copy it into an Excel sheet, say comma separated values, and it will come into different columns. So that's all about moving from unstructured format to structured format. So you have audios, you have video files, images, audio and textual, which is unstructured in its raw format. You can always apply techniques and move it to structured. You have SIFT, histogram of shift invariant feature transform, histogram of Gaussians, many techniques to bring your unstructured data to structured. All these are part of our advanced AI training. Okay, so even if you don't understand, that's fine. Then batch processing versus streaming data. Sometimes you might, okay, I'll take example of same bank. In bank from say 9 a.m. until 5 p.m., 100 people have applied for loan. So you have 100 forms or 100 entries. In the evening at 7 p.m. or 6 p.m., you will run an algorithm which will run through all these 100 entries and then start predicting on whether the people will default or not. When are you doing it? At 6 p.m. at one go. And you are processing these batch of 100 entries. Since you're processing this batch of 100 entries at 6 p.m., it's called as batch processing data. When you have streaming data, that means think about stock market. People who do speculative trading, day trading or whatever you call it, right? They buy one share and then immediately they sell it. They keep doing that. All these transactions are reflected in your bank account immediately. Or think about credit card. The moment you purchase something, immediately you receive a message, right? That some amount has been transacted. Streaming data. All of your IoT sensors give you streaming data. This is yet another variant, right? And then you have big data versus not that big data. What do you mean by that? So big data means any data which is coming at a rapid pace, velocity, huge volume, and variety. Right? These three V, I mean, there are many other things, right? Velocity, volume, variety. Having said this is all fine bookish examples, but if you want to really understand the definition of this, then bear one thing in mind, that you have to look at your as is resources. What are your current resources? As is resources, like how much hard disk space do you have? How much RAM do you have, etc. If that is sufficient for your analysis, that's not big data. If it is not sufficient for your analysis, say you have 2 terabyte file, but you have data which is of 10 terabyte, then that's big data for you. For that scenario, it is big data. Okay. And here again, if you have big data, you store it in Hadoop. If you have data which is not big, then you have to look at whether that data is structured or unstructured. If your data is structured, store it in relational database management systems like your SQL, MySQL, Oracle database, Microsoft SQL, etc. If your data is not big data, and if it is unstructured, then you store it in NoSQL databases such as Cassandra, MongoDB, HBase, etc. Right? So fine. You need to know all these, friends. It's not just about I run algorithm, I get the job done. That any person can do. Right? How are you different? You are different because you understand all these elements which are actually needed for someone to become a successful data scientist. All right, next. Time series cross-sectional versus panel data. Cross-sectional data means data which is captured at a specific point of time. For example, say you want to build prediction model. When you want to build a prediction model, you go to a hospital and that hospital will give you data at that point of time. They might say that, you know what, until now we have 10,000 customers or patients who visited the hospital. Here is the data. Good. Now you'll not go back and ask, hey, can you also give me the date and time when the patient has entered hospital? Obviously, hospital will ask, why do you need that to predict cancer? Cancer or no cancer? To predict that, why do you need the date and time? Do you think the date and time when the patient enters the hospital is going to determine whether they have cancer or not? Absolutely no. So the data which does not need date and time, right? Or the sequence in which you capture the data is immaterial. Sequence not important. Then it is called as cross-sectional data. On the other side, if you want to predict sales or the temperature or the occupancy percentage of aircrafts, etc., these kind of things obviously would require your data to be sorted in the ascending or descending order based on date and time. So date and time becomes important, and the sequence in which you arrange the data is important. In these kind of scenarios, the underlying data is called as time series data. Wow, these two are fine, but then what is this panel or longitudinal data or longitudinal, however you want to call that, right? To explain this, let me give this. Say you want to look at how many people in India, right, have flu symptoms. So what do? You just go, you pull a sample. At this point of time, you'll go pull sample of people, do some medical tests to determine they have COVID-19 or not, or flu or not. Flu and COVID-19 are different, I understand, right? But still, I'm just giving you an example. So you pull it at this point of time. So it will give you just a snapshot of how many people have flu or COVID-19 now at this point of time, at a particular point of time. So at one point of time. Okay. We do not know based on this whether the count of flu, number of patients who have flu or COVID-19 is increasing or decreasing. At this point of time, you don't know because you took it at a specific point of time. Okay. Now, if you follow a single patient, you choose one patient and follow that one patient over a period of time. Okay, say you have taken one patient number one, you're looking at the temperature of that patient throughout. Then that's time series data, a single patient. But then you have something called as panel or longitudinal data. It is also called as time series cross-sectional data. Time series cross-sectional data. This is rather than I monitor a single patient over a period of time, if I can combine multiple patients, patient number one, patient two, patient three, and if I track all of these patients over a period of time, then that is called as panel data or longitudinal data.